All right, Algebra 1A students, welcome to part 2 of lesson 4.4. In today's video, we are going to be talking about two new vocabulary words that go along with the graphing that we did in our last video. Okay. In our last video, we talked about an example where we had a cement truck that was holding a certain amount of concrete in its its concrete mixer. So we talked about the weight of that concrete over how much concrete was in there and so on. So in that problem, the thing that is important for us today is the fact that the truck really could contain any amount of concrete that it wants between 0 and 200 cubic feet, right? It could certainly hold 100 feet. It could hold 150 feet. It could hold 27.3 feet. It could hold 105.7 feet. It can hold any number it wants. Okay, so when that is the case, when your x-axis, your x values, can take on any number they want, any decimal number makes total sense, then you can connect the data points from the table because any point there makes sense. Okay, you can connect the data points with a line on your graph. Some graphs, however, are going to be composed of isolated points. Okay, for example, if you're talking about like, well, how much money does it cost to buy a certain number of t-shirts, where X is a number of t-shirts. You have one t-shirt, you have two t-shirts, you have three t-shirts, but it's not possible for you to buy 2.5 t-shirts, right? You can't buy 2.5 t-shirts. You can't buy 3.76 t-shirts. So in that case, the decimal numbers in between these x values don't make any sense. Therefore, we do not connect the data points, okay? And the difference comes down to these two vocabulary words, okay? A continuous graph is one that we do connect. So in the continuous graph situation, decimals make sense in this situation, okay? Decimals make sense. Whereas in a discrete graph, decimals don't make sense, okay? They don't make sense. For one reason or another, it doesn't make any sense to have decimals as your x values. So notice these are individual separate points here, not connected by a line. That's called discrete graph. Please make sure I see these two vocabulary words written down on your notes. And if I don't see it, I will ask you to go back and write those down. Please write down continuous graph, that decimals make sense. Discrete graph, decimals don't make sense. Okay? Then we can look at different examples of this. So if we look at this cheese making example here, we have a local cheese maker who's making cheddar cheese to sell at a farmer's market. The amount of milk that he uses to make cheese and the price at which he sells it are shown right here. Okay, so 1 gallon of milk makes 16 ounces of cheese. 1 wheel of cheese costs $9. Okay, write a function for each situation, graph the function, and then tell, is it continuous or discrete? That's the important part here. Okay. So if we look at the milk making example, right, we're making the cheese with 1 gallon of milk for every 16 ounces of cheese. Okay, so the weight of cheese in ounces depends on the number of gallons, M, of milk used. So if I use 0 gallons of milk, I make 0 pounds of cheese, or sorry, 0 ounces of cheese. If I use 1 gallon of milk, I make 16 ounces, 2 gallons of milk, 32 ounces, 3, 48, 4, 64, and so on and so on. Okay, so this is something I can graph from that table of values, and I'm going to do exactly that. 1, 2, 3, 4. Okay, and then up here I will go maybe 10, 20, 30, 40, 50, 60. So 10. Okay, so this is my W graph, or sorry, my W axis. This is my M axis. And now I'm going to start plotting these points that I have in my table of values. So at 0, I know I'm at 0. That's pretty easy. 0 and 0. 0 milk, 0 cheese. 1 gallon of milk, 16 ounces of cheese would be right about there. 2 gallons of milk, 32 ounces of cheese, right about there. 3 gallons of milk, 48, right about there. And 4 gallons, 64, which would be way up here. Okay. Now I have to think about, is it possible for me to only use 0.2 gallons of milk? Is it possible to only use 0.5 gallons of milk, 0.3 gallons of milk, or 5.8 gallons of milk? The answer is yes. I can use however much milk I want, so I can take these points and I can connect them with a straight line. Okay? The reason I can do that is because this is a continuous graph. Okay? A continuous graph. Because I'm using gallons of milk, which I can certainly use 0.2 gallons, 0.3 gallons, 0.8 gallons, any decimal number that I want. Okay? The other example that I get is about selling the cheese. The amount A of money made from selling the cheese depends on N number of wheels sold. So I'm selling this cheese by the wheel. I get a bunch of wheels, I sell the wheels, and I make money. Okay, $9 for every wheel of cheese. So again, I have this table of values here, and I have N equals 0, A equals 0, meaning if I don't sell any cheese, I don't make any money. And then my N, which is going to be down here for number of wheels sold, is going to go up 1, 2, 3, 4. And then here in my money, I need to get up to 36. Maybe I'll count by 5s. 5, 10, 15, 20, 25, 30, 35. So this is 5. And this is my money. So I'll put a money symbol up here. That's my money. This is my number of wheels sold. 1, 2, 3, 4. Okay? So again, I'm going to plot these points on this graph because I can plot them from this table of values. 0, 0, again, is very easy, right down here at the start. Then at 1 wheel of cheese, I have $9, right there. At 2 wheels of cheese, I have $18, 15, 20, right about there. 3 wheels of cheese, I have $27, 25, 6, 7, right about there. And then at 4 wheels of cheese, I got 36, which is right up above there. Okay? Now, in this case, because I'm selling cheese by the wheel, it's not possible for me to sell 2.76 wheels of cheese. I mean, I can slice them up, but I'm not. I'm selling them by the wheel. So in this particular example here, it doesn't make sense for me to have decimals, which means this is a discrete situation, and I should not connect these points with a line. So I'm going to leave it just like it is. Point here, point here, point here, point here, point here. 1, 2, 3, 4. I could make another point at 5, another point at 6, another point at 7, at all the whole numbers, right? 1, 2, 3, 4, 5, 6, 7, 8. But I can't do decimals in between, so that's why I do not connect these set of points here. When I was using gallons of milk, I could use decimals gallons, so that was continuous. Here I have discrete because I can't sell a decimal's worth of a wheel of cheese. Okay? If you have questions about the difference between continuous graphs and discrete graphs, or how to tell the difference between them, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.